Hello there. Welcome to another discussion about the indicators of maths difficulties. I am Rob Jennings from the Dyscalculia Network, and today I'm going to talk about place value. This topic nearly always ranks as one of the most difficult and challenging areas of foundation maths. Place value can be defined as the value represented by digits in a number on the basis of its position within that number. It is a key concept for children to get to grips with. Without an understanding of it, they may struggle to add, subtract, multiply or divide, let alone read and write numbers. I think it's such a difficult topic for both the teacher and the pupil because it's such an abstract concept. And I think it's best explained using concrete materials and demonstrations. We can break down the main issues into the following areas. Firstly, the principle of exchange. We need to understand that several items can be exchanged for or represented by one item of greater value. For example, 10 1p coins are equivalent to one 10p coin, or for example, 7 days are equal to 1 week. This principle of exchange is fundamental in mental and written calculations and is related to the value and position of each digit. 10 in any place in a number can be exchanged for 1 in the next place to the left. So for example, 10 hundreds can be exchanged for 1,000. Conversely, 1 in any place can be exchanged for 10 in the next place to the right. So for example, 100 can be exchanged for 10 tens. I find the best way to understand this is to physically move base 10 equipment such as Dean's blocks, exchanging 10 cubes for a 10 rod. Next, it's important to understand the structure of the base 10 number system. Pupils need to understand that this structure for the base 10 has repeating patterns for hundreds, tens and units within large numbers. It's also common for the pupil to misunderstand the value of a two-digit number. They read the number 32 as 32 and can put 32 objects out to demonstrate the value of that number. But when asked to write the same number in its expanded form, they may write 3 plus 2, indicating the values as 3 and 2, not 32. In addition, they may not be aware that the position of a digit determines its value, mistaking the number 306 for 36, or may record 4008 as 408. Next, we're looking at viewing 0 as a placeholder. Pupils need to recognise 0 as a label for an empty set or nothing, as well as a placeholder for numbers in the base 10 number system. Partitioning involves separating out numbers so that the value of each digit can be seen. For example, 385 can be split into 300 plus 80 plus 5. Confidence in doing this will be a prerequisite to adding and subtracting larger numbers mentally and when using a written method. Next, we need to look at reading teen numbers that do not follow the normal rule. Generally, numbers are read from left to right. 25 is read as 25, but our teen numbers contradict this rule as they are read in reverse, 14 as 14. This causes lots of confusion and leads to recording numbers the wrong way round. Decimals. Often people think that 0.67 is bigger than 0.8 because it has more digits. They may have mixed this up as they have read the numbers after the decimal point as whole numbers. They need to understand that for each place to the right of the decimal point, the numbers are successively smaller by powers of 10. Multiplying by 10 and 100. Pupils often say that multiplying by 10 is easy because all you have to do is add a 0 on the end of the number, adding 2 zeros if multiplying by 100. Sometimes a number can be multiplied by 10 by adding a 0 on the end. For example, 8 times 10 is 80. However, this trick doesn't always work. Adding a 0 to the end of a decimal number doesn't change the size of that number. For example, 10.50 is the same as 10.5. When you times by 10, it's better to think about it as moving all of the digits one place to the left, so 10.5 becomes 105. The decimal point's like a concrete post. It doesn't move. Digits are moved past it. One space to the left are times by 10, or 2 spaces when you're timesing by 100. Thank you for listening.